Yes, I know what a sphere is. Sphere is like a ball. Our earth is a sphere, a ball is a sphere. So if we have a ball and we need to find the volume of the ball, volume contained inside the ball, or the surface area of the ball, it shouldn't be very hard to find that, isn't it? Well, but if you look at the formulas, you start wondering, where do the formulas come from? But once we understand where these formulas come from, it won't be a challenge at all, and I promise you that. So come on, let's nail it. Hey guys, my name is Vikas Sharma and I welcome you to yet another video of Exponent to Success. And in this video, we are going to learn about the volume and surface area of a sphere. So without wasting any further time, let's get into the video straight away. Well, so what I'm going to do is I'm going to start with a circle which is placed horizontally. And what we are going to do is we are going to rotate it by 90 degrees in the anti-clockwise direction. So once we do that, the circle then looks like this. And if we keep rotating the circle very fast in the anti-clockwise direction, we will notice that it becomes like a sphere. Now, if we have a look at the sphere, how many faces does it have? Well, I don't see any flat faces anywhere. What I see is just one curved surface. And what we need to figure out is what is the curved surface area of a sphere. Well, we are not going to get into too many nitty-gritties of it because that requires the study of calculus, which you learn in higher classes. But what we do right now is to remember that the curved surface area of a sphere is the same as the curved surface area of a cylinder. I'm not talking about the total surface area, I'm talking about only the curved surface area of a cylinder or the lateral surface area of a cylinder. And if you missed our video on the lateral surface area of a cylinder, just click on this link on the top right corner of the screen and it will take you to the video straight away. So how does it look like a cylinder? See, if we open it up from here and take this side towards the right and this side towards the left, it will start looking like a cylinder, and the same we'll do at the bottom also, and it will look something like this. Now, as you notice, the cylinder has the same height as the height of the sphere, and it has the same radius as the radius of the sphere. The radius of the cylinder is this, and we can take it as r. And the height of the cylinder will be this. And let's assume that the height is h. So now from the last video, we know that the curved surface area of a cylinder is nothing but the perimeter of the base times the height. The perimeter of the base is in this case the circumference of the circle, which is 2 pi r, and the height is h. So obviously the curved surface area of a cylinder is 2 pi r h. Now let's relate the cylinder to the sphere. As I told you, the cylinder has the same radius as that of the sphere and it has the same height as the height of the sphere. But looking at inside the sphere, as we can see that the height is the same as 2 times r, or 2 times the radius. It is just a diameter of the sphere. So we can rewrite this as 2 pi r times 2r, because h is equal to 2r, and then we just simplify it. So 2 times 2 is 4, pi comes as it is, and r times r is r squared. So we can say that the curved surface area of a sphere is nothing but 4 pi r squared. I know it's a little difficult to believe that how come it is 4 times the area of a circle, because if you try to place a circle on top of it, you won't really get it. Well, but if you really do need to understand how it happens or get into too much of detail of it right now, I've linked another video in the top right corner of the screen and you can go and have a look at it. Well, so I keep doing a lot of similar stuff on my channel, and if this is the first time that you're coming here, do click on the subscribe button below the video and get subscribed to the channel. And while you're doing that, do not forget to hit on the bell notification also, because that will ensure that all future content is delivered right into your inbox. Now what we are going to do is try to figure out what the volume of the sphere is. Now again, that requires calculus, so I'm not going to get into that, but all we need to understand is that the volume of a sphere is same as 2 times the volume of a cone having the same height and the same radius. Because if we fill up a cone with water and pour it into inside the sphere, and we do that twice, we'll notice that the volume of the sphere is the same as twice the volume of a cone. And if you haven't seen the video on the volume and surface area of a cone, you must again check it out in the top right corner of the screen. Now in that video, it was explained that the volume of a cone is nothing but one third times the volume of a cylinder. So the volume of the sphere will be 2 times one third the volume of a cylinder, or we can say that it will be 2/3 the volume of a cylinder. And since we know that the volume of a cylinder is pi r squared h, that means the volume of a sphere would be 2/3 of that, or 2/3 pi r squared h. So again, substituting h for 2r, we can rewrite this as 2/3 pi r squared times 2r. And if we simplify this further, 2 times 2 is 4, so it becomes 4/3 of pi, and r squared times r will become r cubed. So we can say that the volume of a sphere is nothing but 4/3 pi r cubed. Well, so there you go. We have figured out what the volume and surface area of a sphere is. Well, but if I have a look at the diagram, it looks quite messy with lots of things going around in there with the radius and the height, and it looks quite messy, quite crowded. Well, but it does look pretty with all the colors going in there, so it does look like a Christmas tree, doesn't it? Well, so what I'm going to do is just clear out this a bit for you and make you just remember that the curved surface area of a sphere is the same as the curved surface area of a cylinder, and that the volume of a sphere is twice the volume of a cone having the same radius and the same height. And then that would look something like this. Well, doesn't it look much cleaner now? So that's it. And the next thing that we need to study about is the frustum of a cone. You know what the frustum of a cone is? Well, if you don't, just click on this video on the right and have a look at that. And why don't you click here on the picture to get subscribed to the channel if you haven't done so already, and have a look at these videos also, because they are going to help you a lot. But as far as the volume and surface area of a sphere is concerned, I think you have nailed it. Take care. God bless.